Navakanth. I'm a senior database architect with AWS ProServe. I've been with Amazon for 7.5 years. I work with external customers in helping them moving away from commercial workloads to AWS. Okay, that's the team I work for. Today we are going to talk about one of the customer story. To begin with, we will start talking about what is the key differences between Oracle and Postgres in terms of transaction handling. So we'll look at some demo as well, where we identified a potential challenge while we are taking the application to the production when we migrated from Oracle to Postgres. And so those challenges will be, we'll try to give an example over here. So today's agenda is going to be, to begin with, we'll try to get the pulse from the audience, what is their understanding about how does Oracle transaction work, and how does Postgres transactions work, understanding Postgres sub-transactions, why it is very crucial to understand this. What is the impact of performance of excessive sub-transactions, okay? And a kind of a demo that we look at, we have a recording. Unfortunately, we cannot do the live demo right away because it takes some time. So we have a recording of it, and then we'll go with the takeaways and Q&A. So let's look at some the challenges that we foresee, right? Some context, the customer I'm talking about is a airline passenger booking system. So you know that, as soon as we walk into the airport, the check-in, check-out process, everything handled by this application that I'm going to talk about. It's an application developed over 25 years, over 20 plus years of timeline. It was written for Oracle. So at that point in time, Oracle was the only system, only enterprise database available. So the customer has built the application natively for Oracle. So it was a WebLogic platform where the business context was written in the WebLogic container, and the entire business logic is written into the database in the form of stored procedures, packages, functions, custom types, whatsoever, pragma functions, whatever. So it was one of the complex migrations that we have achieved. So this product is live on Postgres today. It is handling the customer system. So that's one of the achievements that we have done. So, but during this journey, we have learned a lot. We have seen whatever the architectural designs that we have taken forward had some limitations. Okay, that we are going to look at it. Okay, some context we try to add. So exception handling is very critical for this application because they are trying to capture any exceptions that the procedure emits, and they get trap this exception and display it into the application for the troubleshooting purpose. So just to bring everyone onto same context, I hope screen is visible, right? Okay. We'll try to see some understanding of you on how these transactions work. So for this understanding, I try to create a sample table with 2 columns. One is of number data type and other is character varying. So let's see, what would be the expected output of this particular anonymous block if it is Oracle? So we have first, there are 2 DMLs, nothing but insert into sub-transaction table. One, we are passing the first value field as numeric value or number value data type. Second is text. In the second insert, we have both are character varying. What would be the output of this particular anonymous block? And what would be the count of records in sub-transaction table? Just a guess, no need to be specific. I just want to get what would be your understanding of. Right, 0 records. Same thing, if I try to rewrite the same anonymous block in Postgres, we would see the same response, right? So 0 records. Because as soon as the transaction DML failure, the entire transaction gets rolled back. Now let's look at scenario 2, where we have similar DMLs, but with an exception block. We are suppressing the exception here, just by nullifying it. What would be the output from Oracle? Any guess? 1 record. Yes, 1 record. So let's try to rewrite the same thing, anonymous block in Postgres. So what would be the output? 0. So what did we infer here? So is Oracle wrong or is Postgres correct? Okay. Okay. So see, this is the situation we were into. So when we made this architectural choice of, when we are moving the Oracle business context, I'm talking about 8,000 store procedures. It's a huge system, right? And we haven't seen this long-term vision of we get into this blocker. So, okay, we'll further go, and I'll try to conclude on this. So this is the behavioral difference, right? Let's look at the third scenario. What would be the output from this? So we have same transaction block with an exception. We are just putting out the message onto the terminal. What would be the output from Oracle system? Okay, let's see. Yeah, one record. Because as soon as it sees the exception, it jumps into the exception code. Let's look at Postgres. What happened? So here, there's a slight change. Okay, I can use it. Thank you. So let's look at it. It's not. I need to put it on. Yeah. So it doesn't. Okay. Anyway, I think we are running out of time, so I'll go through this. So here, if you have seen, in order to ensure that, we already have seen in the previous example that as soon as Postgres sees the exception, it rolls back entire transaction. To maintain that state management, I try to add a additional code block with an exception. So independently, each DML, we are trying to add an exception. Okay. So what would be the output? Yeah. The first DML is success, second was failure, third was again a success. So we have two records. Now slightly, let's modify the scenario 3. These are all very simple examples. Sorry if it is boring you, but I just want to set the context prior we go into the details of it. So what would be the output of this? A slight change. See, this is only Postgres system. In the third DML, I'm intentionally failing it. I just placed the screenshots. So yeah. I just need to skip it. I'm in a presentation mode. It's not PDF. It's a presentation. You want me to do PDF version of it? I think I cannot. It's in presentation mode. Sorry, one moment, guys. I just want to. So here the main context comes from here. So we have a parent transaction block, and inside that we have a sub-transaction blocks. In the parent block itself, I have intentionally failed the transaction. What would be the output? Obviously, I've displayed it. So it is 0 rows, right? You don't have anything, and that transaction is failed because your parent transaction itself is failed. So I'm just getting into presentation mode from here. So 0 records, right? So this is very important to understand. Now, why am I talking all this? Because state management is very critical for this application. This was built over 20 years, and I know they don't want to introduce any changes, and it's a highly concurrent system. So what we had to do now? So we went with adding a sub-transaction for any DML. Now, what was the additional overhead in Postgres? So let's understand sub-transaction now. So Postgres, as per the definition of it, it's a smaller code block inside a parent transaction, right? This is for having simpler code blocks, handle the errors in an easy fashion for a common as an application development pattern, right? So most of our scenarios that we have seen outside are demoed using save point, right? So exception implicitly also uses a save point. So going back to the scenario, where we had was we were trying to enclose any DMLs within a begin and exception block. So that is actually causing a sub-transaction, right? So we are talking about 2,000, 3,000 stored procedures having a nested calls. Each nested call further has sub-transaction. So this is the complexity that we are talking about as we go forward. So it's just a pictorial understanding of it. So we have a parent block, parent transaction, and we have two sub-transactions inside that. So we have an extension called PG subtrans infos. I think Bharat is also part of it, part of development of it. It is developed by one of the AWS folks. So this helps us to see how many subtransactions a program has spawned. Let's look at that as well. So the same program, if we, I'm trying to intentionally, I'm trying to run it for a long duration so that I could go in the other session and try to monitor it. So I'm just introducing a sleep function for 180 seconds. And if I try to monitor it, here you can see the tree structure, right? So PG subtrans is a view that I've created based out of the functions given by the other extension that I just showed. So if you look at it, we will get what is the parent transaction, what is the subtransaction, and what is the top level subtransaction that is causing nested subtransaction, all this. So this is only available in open source platform. In any RDS platform, it is not available already. So for us, even this was not very simple to troubleshoot. So we went through the reverse engineering of it, which I will shortly talk about it as well. Okay. Now let's also understand. We looked at Oracle to Postgres transaction behavioral differences. We looked at subtransactions. We understood subtransaction. What is subtransaction cache overflow? Okay. Why it is very critical and why it is very crucial to understand in context of long-running transaction. So, Postgres, I think hard-coded this until version 16. From 17, I think there is some programmability around it. I'm not sure about it, but we can further evaluate. So the number of backend subtransaction per process is hard-coded to be 64 at this point. So if you are crossing beyond 64 subtransaction, it gets built into the disk. It doesn't fit into memory, right? Doesn't keep in memory. Now, okay, this is good. Subtransaction caches overflow is nothing but if you have more number of subtransactions greater than 64, it spills into the disk. But in what context that we need to understand this? So you have, so this is, the visibility of your transaction is between your xmin and xmax, right? So you need to maintain your xid array and sub-xid array in your memory. So all the concurrent transaction has to look up these arrays. If not doesn't exist in array, it has to go to disk and do a lookup, which is an additional IO, right? If you look at a concurrent system, I'm talking about passenger booking system with a high concurrency. So one long-running transaction is impacting entire their TPS, okay? So their TPS has drastically dropped. From the NFR testing they have conducted to the productionization, it was actually not, it doesn't match to any extent, okay? So as I said, having subtransactions is good until we are not overflowing the cache. And if you are overflowing the cache, and that too with a long-running transaction, this is a painful thing to monitor. So the customer I worked with was running on version 14. So there is no particular view to easily troubleshoot. So we had to do a lot of things. We have to deep dive, understand the program code. Okay. So one thing we nailed down was, prior to version 16, the PGStat SLRU view has a subtransaction section where we started seeing the read. I don't know whether you're able to see on the screen. There is blocks read. So we started seeing these block reads kept on incrementing. So which means it is started reading the disk because it's not able to find the transactions in the memory array. So it started looking up into the disk. So that's how we tried to troubleshoot. From version 16, there was a new function introduced to understand whether there was an overflow or not, of the subtransaction buffer or not. So before we go into demo, I just want to put out this thing. This is a view. This is a snapshot taken from AWS Performance Insights. This was simulated. This was not actually the customer workload. This was a simulated workload, just to prove that when there is an overflow of a subtransaction buffer, and when there are concurrent transactions, we just run intentionally. We have overflow on the buffer. In the parallel session, in the other session, we have tried to run PG bench workload. So you can see that these transactions started to read. There is a IO wait event, IO wait class, where it is trying to read the SLRU buffer, and we also have a lightweight lock on both subtransaction buffer and subtransaction SLRU. Okay. Let's look at some demo. So this was again recorded on the customer environment. Okay, this was a simulated work environment. Sorry, it was stuck. It was slow for a minute. What we did was just to explain, we created a parent transaction. We had nested to an extent that it is overflowing the buffer intentionally, right? Transaction within transaction within transaction within, so that we have intentionally overflown we have created more than 64 sub transactions, so that it overflows this situation. So let's look at. So we have this program. So in the last inner nested block, we are keeping a sleep, so that we could go to the parallel session and monitor it. So we are just running the program, and we are trying to see if overflow bit is set or not. See, you can see that. Okay, let me pause here. I don't know how to. So here you see the sub transaction overflow is being enabled. So we have simulated that scenario now. Let's run PG bench workload in the parallel session. So if you see SLRU is the block reads are not still populated. This gets populated once we start simulating the PG bench. Again, this is a simulation that we are actually doing for actual performance issue we had in the production. This is the AWS Performance Insights view. Okay, we are initiating the PG bench workload. PG bench workload is initiated. Maybe I'll try to speed up a bit. Ooh. 54 minutes. Sure, thanks. Yeah, we are just running the PG bench, enabling all the environmental variables. PG bench is initiated. Let's look at the stats view. So block hits is nothing but in memory. Block reads is the area of interest. Let's wait for a few more seconds before we see. So already we see that overflow is enabled. We have already overflown the buffer. We are parallelly monitoring the wait events. As soon as the sessions start reading the sub-transaction buffer, and if it doesn't find in the sub-transaction buffer, it has to go to the disk. We start seeing the disk reads, which is nothing but blocks read. We could also use the PG weight sampling. Here we have a leverage to use AWS Performance Insights. That's the whole reason we were focusing on it. We're just waiting for that thing to happen. Meanwhile, if you have any questions, so we started seeing the block rates, right? So, which is an indication that now we started seeing that wait event. So if you go to the performance insights, we'll start seeing that thing coming up, right? Lightweight lock on sub-transaction buffer, sub-transaction SLRU, and IO wait event on SLRU, right? So these things will come up. So we started seeing that, there is a lightweight lock on the sub-transaction buffer to read the transaction IDs. The number of reads on, but with this number of block reads are spiking up. So we see that all the wait events are appearing now, right? Okay, I'll stop here. Maybe just want to, once this long-running transaction is killed, the wait events are gone. Now I'll stop there. I'll go into the presentation. So just to give you an idea that, a long-running transaction with a sub-transaction overflow can cause a lot of pain in the application performance. So in our case, the TPS has reduced by 50%. So this is an airline passenger system where reservations are very critical. Okay, and reduction of TPS by 50% is a huge penalty. Now, how did we overcome this problem is by setting up proper monitoring. There is no workaround. We cannot go back and rewrite entire code that has been remediated, right? So we identify the transaction that is causing this problem or long running with a lot of sub-transaction and focus only on that program to rewrite. That's the way forward we have taken, and we've achieved it. We're successfully able to do that. Additionally, we have set up the right monitoring onto the proper metrics so that next time when there is such situation, we could properly handle it. So again, takeaways from this thing, from this learning. Postgres sub-transactions are a powerful feature, yet it has to be efficiently utilized. We cannot keep sub-transaction running for long durations, right? It might impact the overall performance of your database and moreover application. So careful monitoring has to be enabled. That's our learning. And there is a future work being in this area where there is customization to this value that is proposed. I'm not sure what is the state of it, but maybe Bharat or someone can give us some idea on that. Okay, I think with that I'll try to close this. Maybe open for the questions. Yes, close monitoring and okay, sure. So the question is there a plan to rewrite the application? Because since this application was originally built for Oracle, now that it was migrated to Postgres compatible, is there a plan to rewrite the application? That's the question. So no, there is a complete new modernization plan. They're looking at microservice rewriting to microservices-based architecture. It's a 3-year long-term vision. So right now they don't have it in there because it's a very complex system. As I said, it's a WebLogic container where the business context only is present. The entire business logic is in database, right? So this has to be. How can I rewrite the application? Application doesn't know the business context. You're getting me, right? So business logic, I mean to say. So it's not that easy. That's the whole reason we were not able to do further anything. Okay. Any other questions? Yeah, please. Right. Right. No, we cannot. There is no way. I mean to say, this is coming with congruency. It's not coming with single program, right? So I agree with your point that any program. So there is if-else clause, right? So if there is a specific satisfaction of certain condition, it goes into the loop. Else it doesn't. So it's not always true that a developer could know it. So there could be a lot of, as I said, this is not a simple code to troubleshoot, right? I'm talking about And nested transactions, this could be based on certain conditional evaluation. Um, there are a lot of file operations as well. So file operations depends on the volume of data that is coming into, right? It needs to go through multiple loops. So it's not that easy, even during the initial code push that we could detect it. Yeah. For us, it was not easy actually. I mean, I'm not sure whether if it is a simple code, there could be a possibility, but for us, there is no possibility. Any questions? Any more questions? Yeah, Ranga. No, as I said, it is coming default. Oh, sorry. Okay, my bad. So the question was, is there a configurable parameter that could alter this behavior in the Postgres engine? That was the question. No. Okay. The configuration for sub-transactions. The answer is at this point no. It is coming through during the compile time, so there is no way we could alter it once this instance is launched, right? So, but there is a future work that being discussed to make it more configurable. Yeah, there will definitely be, but the future scope is not to just increase the number of sub-transaction. I think there was a complete email thread discussed about some other optimal way of doing it. I'm not very particular about it. Yeah. Use case, sorry. Okay, so for us, the customer, one of the airline went live, and as soon as they went live, one of the module, which is very business critical for their functionality, triggered this behavior. That's the root of it. So this module was not aggressive in other low carrier, low frequency airlines. So it was actually piloted with a low frequency airline, then taken it to the medium frequency airline, and then it was taken to the large category of airline, right? So this pattern was not observed in any of the other deployments. This only came through when it has been taken to the large passenger airline provider. Then we started doing a reverse engineering to, from the wait event, we started drilling down to the sessions, transactions, and that's how we found out one module was causing it. We have rewritten it. So that problem has gone away. But still, there are, as I said, this was a design pattern we have chosen in the beginning, right? Enclosing in order to maintain the state, right, we will have to enclose within the exception so that, there is no transaction failure. You got me right. So the state is persisted. So they need to have this oracle-like behavior. Okay. Mhm. Okay. So as I said, this has been not observed with low concurrent passenger airline provider. It has been only come when it was deployed with high concurrent airline provider. Okay. Any questions? Yes. Yes. I'll take this question. Yeah. No, it is never been disclosed. Never been identified. Even with a lot of NFR test suite, this issue has never been identified in the low frequency carriers. You can say that because this product was supposed to handle 15 airlines, 15 to 16 airlines, I suppose. So only when it went to the larger category of airline, we started seeing this behavior. Yes, please. Sub transaction. Yeah. Mm. Yeah. Both. So a long running transaction with a sub transaction count greater than 64 is causing this pain. How could you know that 64? So only if you run the workload, you'll get to know whether there are 64 sub-transactions. When you're developing a program, you will never know that it is, because this is a modular architecture. It is not a single, you don't write a program in a single stored procedure. You call certain other function, certain stored procedures. So it has never been easy for your, during your development, you'll never be able to make this out. Because when you are developing, you will only know that, when there is an exception, you need to handle it. That's the only thing you will know. You'll write. Right, both. We were trying to do both. Yeah. I think, thank you. Thanks, everyone.